All right, 7.6. Now we're going to take what we did in 7.5, the rational equations, and put it into an application, problem solving. These ones tend to be a little more difficult because you've got to make the equation yourself. And you've got to be solid on solving them so that once you've got the equation, you can keep going from there. But the hardest part of these is to make the equation to start with. So let's just make sure your solving is good. Again, try these and then see if you get the same thing that I do. It's great. Pause it, work it through, and then check with me. There we go. So the method that we're going through, multiply by the LCD. So we first of all got to say, ooh, V cannot equal 0, and then our LCD is going to be 4V. Does that go for 1? So take every term, multiply by 4V. Divide before you multiply. So then the V's cancel off, the 4V cancel off, and we get left with 8 minus 5 is equal to 12V. 8 minus 5, that's 3 equals 12V. Divide by 12. V is equal to 3 over 12, which is 1/4. That's not the restriction, so it's good. Let's try the next one. M cannot equal -3 or +3. And my LCD in this one, M plus 3 and M minus 3. So bracket them off and multiply. And gone, 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 gone. That gives us 4 times that equals 1 times that. Distribute in, and you come up with 4m minus 12 is equal to m plus 3. And now just solve for m. Bring your m over. So 4m minus the m equals 3 plus 12. 3m is equal to 15. So then m is equal to 5. Just check to make sure that's not one of the NPVs. Nope, so you're good. All right, so now we start getting into a little bit trickier of a problem. Blah, 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 all the way through. The biggest thing you have to remember right now is distance is equal to speed times time. All right, let's go through this. Mario drove from Edmonton to Grand Prairie and back, a distance of about 360 kilometers each way. Mario's average speed was 30 kilometers greater than on his return trip than on his trip out. His total driving time was 10 hours. Determine Mario's average speed on each leg of the journey. So let's completing a table. In the book here, they're giving the table this way. I showed you the table this way in the last one, and I tend to do my tables this direction. Whichever table works for you, use that. So as we're filling in the table, I would like you to try to work this through, think it through yourself first, see how far you can get on your own. Always pushing yourself, challenging yourself, because chances are when you get to an exam, it's not going to be exactly like you've seen. So if you've gained the skills of being able to challenge yourself, you're going to be much better off. First thing you have to realize on these is this a total or an equal question? Whenever you get the distance, speed, time questions, there's two varieties. One which I'll call a total question, one which we'll call an equals question. So we look and we say, does one of these columns come up with telling me something about it being equal or that it's a total? In this case, I'm told here, I've got total time. So I'm going to highlight that, because that's the one that I'm going to use the formula on, the equation, the D equals ST. Whichever column here is either equals or totals is the one you're going to use your equation on. Let's look at this one. Start by figuring out what are our two different criteria here. We've got on the way there and on the way back. So I'll just call it there and back. They called it Edmonton to Grand Prairie to Edmonton. And I'll fill in both of these at the exact same time, so you, whichever one you are using yourself. The first column or row in this one that you want to fill in is the one that they give the information to. They say a distance of 360 kilometers each way. So I know the distance there, I know the distance back. Both of them are 360. So that's the one you fill in first. And the second one you fill in is not the one I've highlighted, but it's going to be the one that we're going to use the variable on. So I need to use a let statement here. I need to get some variable. Choose a variable to represent. So we have to say let, well, let's say x equal Mario's average speed equals Mario's speed there. That's my x. Define your variable. If you are using a variable, you've got to define it. So I'll say on the way there is x. But on the way back, his average speed is 30 kilometers greater than it was there. So that means his speed coming back was x plus 30. Now I'm going to use the formula into here. I'm looking for time, so I've got to isolate time on this formula and rearrange it. Time is equal to distance over speed. So the distance, which is 360, over the speed, which is x. Distance, which was 360, over the speed, which was x plus 30. I've got total driving time. Oh, I'm going to fill in this one for you down here. So this was x plus 30, and then 30 over 360 over x, and 360 over x plus 30. We have an extra little box here, which we're going to call total, for the total time. And the total time is made up of taking the time there and adding the time back, and that was 10 hours. Now we're ready to do our equation. So take the driving time for on the way there, which is 360 over x. Add to it the time on the way back, 360 over x plus 30. And that's going to equal 10, a total. Hey, this is exactly now what we've done. What's your LCD? What are your restrictions? Let's start there. First of all, the restrictions. Well, x can't be negative 30. X can't be 0. Well, of course it can't be. It's a driving time. We know that it has to be greater than 0. You've got some speed. You're not going to be doing a negative speed. You're not going to be doing a speed of 0. That won't get you anywhere. So we know that the speed has to be some positive value. If you get a negative value at the end for x, it's extraneous. And let's get our LCD. LCD is going to be over 1. We've got x and an x plus 30. let's multiply each of them by that. Divide before multiplying. Don't forget this part. When people do these types of questions, they forget to multiply the 10 by the x and the x plus 30 as well. So watch out for that. And now we've got 360 times x plus 30 plus 360x equals 10x times x plus 30. And expand them. So 360x plus 1080 plus 360x equals 10x squared plus 300x. Got a quadratic? Equate to 0 and factor. So let's equate it to 0. Bring it all to one side. 10x squared minus 420x. That's 10,800. Hey, I can factor out a 10 out of all those, so let's do that right now. Divide everything by 10. We're only able to get rid of this 10 when it's equal to 0. Otherwise, factor it out and keep it in front if it was equal to something else. Okay, and then we get, at this point, we've got x squared minus 42x minus 1080 equals 0. And refactor, which factors into x minus 60 and x plus 18 equals 0. So either x is equal to 60 or x is equal to negative 18. That don't make any sense. Negative 18 kilometers per hour, not going to happen. We're talking not about vector quantities, so that's an extraneous. We have to make sure that x equals 60 makes sense. Let's go back to what is the meaning of the x. We defined x to be Mario's speed there. 60 kilometers per hour there, plus 30 on the way back, 90 on the way back. Hey, those are acceptable speeds. So then, that's the average speed. So we need to have written question, written answer. And we actually want to, first of all, make sure that this makes even more sense right from the very problem. So do a quick check. So how far does it get to there? Go right back to the problem, get the information. Say, okay, the time to go there would be the distance, 360, divided by the speed. So let's check that out. Okay, so just do a quick check for yourself. Always do this to see, does it make sense? Okay, on the way there is 360 divided by 60, which gives me 6 hours there. Okay, if it's got to be a total of 10, on the way back he better have taken 4 hours. Let's check. Time on the way back is 360 over 60 plus 30. 360 over 90. 4 hours, yep, that gives me a total of 10 hours. So yeah, 60 is going to work for it. Once you've done that, you can make your statement. Mario traveled 60 kilometers per hour there and 90 kilometers per hour back. All right, so here's another real-world problem involving motion. Boat travels an average of 15 kilometers per hour in still water. Boat travels 12 kilometers downstream in the same time as it travels 8 upstream. Determine the average speed of the current. First thing you have to decide, is this a total or an equal question? And they're saying same time. Same time is equal. So let's go through and set up our little chart. Distance, speed, time. We're traveling downstream, we're traveling upstream. So down and upstream. Whichever thing that we say is equal or total is the one that we need to use the equation, the formula for. So then time is equal to distance over speed, again for this one. That's the last column that we're going to do. First column is going to be, what information do we know right now to fill in? So we know 12 kilometers downstream, 8 kilometers upstream. Let's put those in. So 12 kilometers downstream, 8 kilometers upstream. The next column is the one we're going to use the variable for. So we need a let statement. Let, let's just use x, s, whatever variable you want to use. So let's let x equal speed of current. Almost always, your variable here is going to be defined by what you're looking for, average speed of the current. And that's almost every single time the case. Not always, but most of it. So let's fill that in. The speed downstream. The speed downstream is how fast you're going, how fast the boat is going, still water speed, plus the speed of the current. The current is pushing it. And so it's going to go faster downstream than it will be able to go upstream. Same kind of thing would be with wind and against the wind. Downstream is still water speed, which is 15, plus the current speed. Coming upstream, your boat's going at 15, but you're going to be going slower by the speed of the current. The current will be holding you back. And now let's use our formula, d over s. So 12 over 15 plus x, and 8 over 15 minus x. That's really the most important part of the problem, is getting it put into here correctly. And now we have an equal, so we're saying equal time. That means these two boxes are equal. Pull those out and make them equal. 12 over 15 plus x equals 8 over 15 minus x. So my x value cannot be equal to negative 15. Well, wait a minute. But this is, again, a speed of a current. It has to be a positive value. So even if I get a negative value along the way, it doesn't make any sense. But x can also not equal positive 15. X couldn't even be more than 15 either. Because if x is more than 15, that would mean that our speed would be going backwards. The current would be pushing us faster than the boat can go. So we know that our answer better be somewhere between 0 and 15. And now LCD is equal to 15 plus x times the 15 minus x. And multiply both sides by that. And gone and gone, gone and gone. And that leaves us with 12 times 15 minus x equals 8 times 15 plus x. Distribute in and work it through. 180 minus 12s is equal to 120 plus 8s. Combine your s's. 60 is equal to 20s. Divide by 20. S is equal to 3. Now, does that make any sense? First of all, is it between these two? Yeah, it's between 0 and 15. And it's lower than that by quite a bit. So yeah, that's starting to make a little bit of sense. Let's go back to the information and make sure that it works. Your time was 12 over, well, 15 plus 3, so 12 over 18. Let's look at the other one, which is actually 2/3. And we've got 8 over 15 minus 3, so 8 over 12, which is also 2/3. So yeah, those are the same times. This is the right answer. Just box that in and give a written answer. The speed of the current is 3 kilometers per hour. Example number 2. And these are the real-life problems that are involving work, okay, or the fraction of work that people do. For this one, again, you may want to go through, and I highly recommend that you read through their examples. They give information. They're explaining as they're going through as well. These are tough. You may not understand it as I go through the first time. Read their example, okay, and then bring your questions into class. So Marissa can paint a garage door in 3 hours. When Marissa and Roger work together, they can paint the same garage door in 1 hour. How long would it take Roger to paint the garage door on his own? All right, well, let's go through all this. Marissa can paint the garage door in 3 hours. So in this 1 hour, if she can do it in 3 hours, how much of what fraction of the door is she able to paint in that 1 hour? Well, it's going to be 1/3. Because if it takes her 3 hours, she's going to be able to paint 1/3 of it in 1 hour. So Marissa's fraction is 1/3. And then there's Roger. There's Roger's fraction. What percent of the door can he paint? Well, if she's painting 1/3, he's obviously painting the other part. We're just going to call it, though, 1t. 1 over t. So that's the rest of the fraction. And all that together, her fraction plus his fraction have to equal 100%, or 1 whole door that's being painted. And now we just work it through. We know that because t is talking about his fraction, well, we know that it's got to be a positive number. It's got to be greater than 0, just out of the context. And our LCD again is 3t. So multiply all of them, including that 1. This is the one that people make the most mistake forgetting to multiply by. Watch yourself so that you don't do that. I'll just highlight it just to make sure you don't forget about it. And then divide first. T's gone. Leaves us with t plus 3 is equal to 3t. Bring the t's together, so 2t is equal to 3. And divide t is equal to 3 over 2. 3 over 2, well, because we're talking about hours, we want to know how long would it take Roger to paint the garage door on his own. See, the 3 was where she painted on his own. T is what he's able to paint on his own. So that's equal to 1.5 hours. And that makes sense if you think about it, because if she's able to paint in that hour, she's painting 1/3, he's painting 2/3, that means that he's working twice as fast so it should take them half as long. So always be looking, do my numbers make sense? And yeah, they do there. So then Roger takes 1.5 hours to paint the door on his own. All right, so the next one is proportions or ratio problems. Okay, how much lemon juice must be added to 2 liters of water to make a lemonade solution that contains 20% lemon juice? Well, let's get a let statement first. So let's use V for volume, okay, because I want to know how much lemon juice must be added. So that's what I'm looking for. That V equal the volume of lemon juice added. You have to identify what your variable means. If you use a variable, you've got to identify it. And so now we've got a proportion. I take the amount of lemon juice out of the total. I started with 2 liters of water, but now I have 2 plus V. So V, which is the volume of the lemon juice, out of the total, which is 2 liters of water plus the lemon juice, has got to be 20%. 20% is 20 out of 100. So 20%. Well, here we go. Let's work it through. We know now as well for our problem that the V has to be greater than 0. It's got to be positive. And we know it can't be equal to 0 because if I add no lemon juice, there's no way I can get 20% lemon juice. So we know that I got to get some positive value. The NPV says that V cannot equal -2. Well, yeah, we know that. That doesn't really help us here because we already know that it has to be a positive value to make sense for this whole question. So looking at our value here, actually I'm going to do one thing first. I'm just going to take it down to 0.2. So you can use it as a whole here, or you can use it as a decimal. Either way would work. I'm going to do it over here 2 different ways for people that like to do it with a decimal, 0.2, and this one, which we'll use. Our LCD over here is going to be 2 plus V and 100. 100 and 2 plus V, and 100 and 2 plus V. So, for those of you who don't like decimals, using this method works. And if you don't mind decimals, using smaller numbers, this method would work. And then this one, you'd be multiplying by 2 plus V. So whichever method works for you, use one of them. I'm just going to keep going with this method without decimals. Most people prefer not to use decimals. That goes off, leaves us with 100V is equal to 20 times 2 plus V. Distribute that in. 100V is equal to 40 plus 20V. And then combine your V's together. So 80V is equal to 40. Divide by 80. V is equal to 0.5. Now let's check. Does that make sense? Well, got to check if I get a 20% solution. If I put 0.5 liters into 2 liters plus the 0.5, so 2.5 liters, does that give me 20%? Divide them 0.2. Yep, that's 20% solution. We're good to go now here. So give your last statement. The volume of lemon juice added is half a liter.